So hello everyone, welcome back to the another lecture. So in this lecture we will talk about gate drive for the dynamic characteristics. Okay. So in the last class we have talked about the what is a gate driver, what is the basic functions of gate driver, why isolation is very important in the gate driver, and how we can give that isolation like magnetic isolation, capacitive isolation, and inductive isolation, and who determine the drive strength of the gate driver. So these very basic things we have talked in the last class. Okay, now we will go in the block diagram of the gate driver. Okay, so when I talked about the gate driver, so gate driver is a combination of how many things? Okay, only gate driver IC is enough to represent the whole gate driver, or there are some other component as well which are important, right? So those things we will talked about. Okay, so let's get started with this lecture. So initially we will just revise few things, we will go in some basic things, and then we will come to the block diagram of the gate driver. Okay, so start with the introduction. So few theory points are written down, I will just read it out for you so that you will your previous class revision will also be done and you will understand few things from here. So gate driver, what is a gate driver? So gate driver is a main link between the world of control and the world of power in the power conversion system. Okay, and the word of control includes the various voltage level like 1.8 volt, 3.3 volt, 5 volt with limited current generated by microcontroller. We have seen that. So microcontroller will generate the pulses of 1 and 0, right? And these pulses we cannot directly give to our device. Okay, so we need something in between this which will take these pulses as an input and generate my desired current pulses to give to my gate of the device, so that device is turned on, right? So limited current generated by microcontroller, which while the word of power include up to the thousands of volt and thousands of ampere delivered by the power devices, right? For any device characterization, the gate drive is a critical because it greatly affects the switching behavior of the device under test, right? So how you are going to give the pulses to the device, that is very important. So accurate pulse generation and accurate pulse given with very less loss and all is very important. So that is why gate drive is very important thing. So in this lecture what we are going to discuss, we are focusing on the gate drive design in switch or switch based DPT circuit for dynamic characterization of wide band gap devices. Okay, so we will learn that what is the gate, what is the how to design the gate driver. Okay, and what are the different component require only gate drive, what is a combination include in the gate drive, everything we will see. So what are the key features of the gate drive? We have learned in the last class also. So good gate drive is able to efficiently and reliably control the power devices under static, dynamic and fault condition. So it is not like that function of the gate driver is to only collect the pulses and rectify, amplify them and give to the gate of the switches, right? This is not only the case, this is in the static case, but what happen when the suddenly load changes or any parameter changes, that time also this gate drive should handle all these things and it should respond accordingly. Similarly, if the fault or something will happen, then this system stop by itself, right? Because when the fault condition is happening, the circuit should be turned off. And how you can turn off the circuit? By not giving the pulses to the switches. As the pulses are not given to the switches, then my circuit will be in the off state, right? So that is the case. So this my gate drive should be capable to do all these things, then only this is a efficient gate driver. Okay, so in the maybe fourth lecture we will see that how the fault conditions are detected by gate driver, what are the different things are there involved to do all these things. So what are the different features available, protection features available in the gate driver. So all these things we will cover. Now specifically in the static state, a good gate drive can keep the device in on state while minimize conduction losses. So this is also very important point, that whatever gate driver we are using, it should have very low losses, right? Because if losses are more, then efficiency of the system may going to be degrade, and that is not the our requirement in power as a power electronics engineer, right? So it is very important that it should have very on state conduction losses are minimum, and keep the device safely in off state to prevent the spurious change in the switch state due to external or internal disturbance. Okay, so it should, my gate drive should be handle this internal or external disturbances. So these all features should be inherent. Okay, this feature should be there in the gate drive. During the dynamic transient, a good gate drive is capable of driving the device from a on to off and off to on state with fast speed and low switching losses. Okay, so switching losses should be less, and this thing will happen very fast. Acceptable electromagnetic interference and low voltage spikes and parasitic ringing. Okay, so this is also the important feature. In case of any hazardous situation, the gate drive can quickly and reliably protect the device, including a typical shoot through, overcurrent or over voltage, over temperature fault. Okay, so these are the different faults. So we will learn this thing in upcoming lectures, that what is the shoot through, what is the overcurrent, what is the over voltage, what are the protection available for over voltage protection, overcurrent protection. So these things are very important. Okay, it is not like if we are if the signals generated by this are over current or over voltage, so that is not acceptable to my device, because device has some standardization, right? So that time how to protect my device, so these things also there in the gate driver. So all these things we are going to learn in upcoming classes. So this is just some key features, that in any faulty condition my gate driver should be protect my device. Okay, because device protection is also very important. So these are the some key features. I hope so you have understood something from the last two slides. If you have not watched previous video also, you will understand that okay, the gate drive will amplify my signal, okay, and give to the device. What are the different key features requirement for the gate drive, those also you have learned. Now we will begin the next slide. Now the basic functional block diagram of the gate drive. So this is the basic functional block diagram of the gate drive. So what gate drive include? So this whole circuit represent the gate drive circuit, not only the gate driver IC single, only gate driver IC is not the gate drive circuit. So there are other parts also which are the part of the gate drive circuit. So what are those parts? So signal isolator is there, then isolated power supply is there, then my gate driver IC and buffer if there. So this is the optional part. Then all these things are there in the gate drive circuit, and then the pulses are generated and given to my switches. Okay, so these are the important things. So you just keep these names in your mind, that what is the basic block diagram of the gate drive, and what are the components inside in the gate drive circuit. So what are the components inside? So signal isolator is there, isolated power supply is there, gate driver IC is there, and my buffer optional is there. Okay, so this is the basic functional block of the gate drive. So far you have learned about the basic functional block diagram. Okay, now we will move forward. So what are the component I have talked you? Gate driver IC. So what is gate driver IC? So it is used to amplify the driving capability of the logic level control signal from microcontroller to drive the power devices. In case of driving capability provided by gate driver IC is not sufficient and extra buffer circuit is added, this can be commonly observed in the gate drive design of power module for high power application. Okay, so that is the use of my extra buffer, which is optional. Okay, if you are working on the high power module application, then that time this extra buffer is generally used. Then second thing I have talked to you about the signal isolator. So what this signal isolator will do? It provides the galvanic isolation between the word of control and the word of power due to their potential differences and noise interference. So this signal isolator will isolate, it will provide the galvanic isolation. Okay, so what is galvanic isolation? That is the separation of the two signal, so that safety is there. Then the third is a isolated power supply. So if I have my IC, I need to supply it also. Okay, so the isolated power supply is the power the secondary side of the signal isolator gate drive IC and buffer circuit. So what is the secondary side of the signal isolator? So there is a primary side. Okay, one is a primary side. So there is a primary side, okay, and there is a secondary side. So generally this isolated power supply I am going to give to my secondary side, okay. So this is what I wanted to say. So you have some gate, some basic understanding that what is a gate driver IC will do, what is signal isolator will do, and what is isolated power supply will do. Okay, now we will go in detail about all these things. Now in the next slide, design of gate driver. Okay, so now what gate driver I wanted to design. So this is a typical gate driver which generally we design. So what things are there? So I have my signal available from microcontroller. Now the signal which is available, that I am initially give to my signal isolator. What this signal isolator will do, it will isolate this microcontroller input and give the isolated output. Okay, because if there is any disturbance or something, so that should not be reflect on the secondary side. So that is why signal isolator is used. Then I have my isolated power supply, that is VCC and VEE. This is my isolated power supply. So you have, if you watch this playlist from the start, you know that VCC and VEE. So VCC is a positive gate voltage required to turn on, and for the wide bandgap devices, negative voltage is also very important. Negative gate pulse also very important. Okay, so this thing we have already talked. Okay, if you don't know the logic behind this, what is the concept behind it, you can watch my previous lectures. In the lecture 1 or lecture 2, I have discussed this thing. Then I have my gate driver IC. Okay, then after gate driver IC, I have my gate resistor. This is RG, my gate resistor, because to limit the current. And then I have my decoupling capacitor C1 and C2. So what is the use of decoupling capacitor? What is the use of this gate resistance, isolated supply? Everything we will see in the upcoming slide. So design of the gate driver. So if you want to see the circuit in a more practical way, so this is how actually, if you have the two switch connection, okay, double switches in one leg, that time this two different gate driver are used. One will be give to upper switch and another will give to the lower switch. We have seen this thing also in our previous lecture, that what are the different types of the gate driver: high side gate driver, low side high side gate driver. So this thing we have already seen, right? So this is the overall block diagram, overall structure. Now we will learn one by one what is the use of this isolator, what is the use of gate driver, what is the use of isolated power, what is the use of power supply, what is the use of this my gate resistor, and what is the use of this my two decoupling capacitor. Okay, so all these things we will learn now. So let's start with the signal isolator. So signal isolator, basically it will isolate the my microcontroller signal and gate driver, and it will give to the gate driver after isolation. Okay, so you first know about the what are the different isolations available. Okay, so basic isolation meaning it will isolate only by single layer. Okay, input and output is isolated by single layer. But when there is a very much more importance on the safety side, protection side, that time double isolations are used. Okay, so two layers of isolations are also used. Then there is a third kind of isolation, that is a reinforced isolation. What is a reinforced isolation? Reinforced isolation is a kind of single layer isolation but having the strength of double isolation. Okay, I have to reduce my cost. Okay, I have to reduce my power density, and by doing that also I have to achieve the capacity of the double isolation. So that kind of isolation circuit is called as a reinforced isolation. Okay, so it is a single layer isolation but having the capacity of the two layers. Okay, so in this way this reinforced isolation is designed. Now some theory part is written down about the signal isolator. So signal isolator provide the galvanic isolation between the ground of microcontroller and the ground of gate drive, and safely transfer the control and fault signal from input to the output of the gate drive. Galvanic isolation capability and common mode transient immunity are a key criteria for signal isolator selection. So what are the two key criteria for selection of signal isolator? If I wanted to select signal isolator for my device under test, okay, yeah, if I am designing my gate drive, okay, if I am designing my gate drive, then I need signal isolator first part. So how should I select the signal isolator? So what is the important criteria? So galvanic isolation capability and CMTI. What is the common mode transient immunity? So common mode transient immunity is defined as the maximum tolerable rate of rise or fall of the common mode voltage applied between the two isolated circuit, and unit is kilovolt per microsecond, and this should be as high as possible. Okay, so what is common mode transient immunity? You just read it out, you will understand, and this value should be high. So common mode transient immunity and galvanic isolation are the two important parameter I have to look for when I will when I will go for the selection of the signal isolator. So this thing you are seeing here, so this is again the signal isolator, the same thing I have shown here. Okay, so you understood here what are the different isolations available, what is signal isolator, what it will do, and if I wanted to select the signal isolator for my circuit, for my gate drive, so these two important criteria are important. So we will solve one case study problem where I will show you numerical values and how to select from the data sheet everything about the if I have something, if I have some device and if I have to design my gate drive for this device, then how we can select all the parameters. Okay, so that thing will cover in the next class. Now the summary, what are the terminology for signal isolator voltage isolation? Okay, so signal isolator voltage isolation, some terminologies are there. So maximum repetitive peak voltage, working voltage, maximum transient isolation voltage, isolation withstand voltage, maximum surge isolation voltage. So these few things you should look in a data sheet when you are buying or when you are designing any signal isolator. Okay, so this thing you should keep in your mind. Now the next thing we will talk about the isolated power supply. So isolated power supply is a gas tank of gate drive. So if without any supply, how my circuit will work, right? So that is why it is called as a gas tank. It provides the required voltage for the operation of the gate drive circuit. Also, it offers the necessary voltage and power for driving the switch on and off state. Okay, so for switching on and off state, it will provide the necessary voltage and power. Power supply also should be capable of providing the sufficient galvanic isolation and CMTI. So the criteria for selection of the isolated power supply again the same. What are the two criteria? It should be sufficiently provide the galvanic isolation and it should have a very good common mode transient immunity. Okay, small input to output capacitor indicate the high CMTI capability. Okay, so if why I have written down this point, if you see the data sheet of the isolated power supply available, there they will generally mention the input to output capacitance value, and this value may be in the nanofarad range. Okay, so lower the value, better the CMTI capability. Okay, so that is why, so generally sometimes they will give this value or they will mention the input to output capacitance for isolated power supply in the nanofarad range. So that from seeing that thing in the data sheet also you can understood that okay, this isolated power supply have high CMTI capability. Now power rating requirement of isolated power supply can be expressed as, so what is the output power requirement? So isolation power, then my gate drive power and my switching converter power, my switching power. So combination of these three will be the overall power requirement of my isolated power supply. So here you will see the circuit. Okay, so this is kind of VCC and VEE I require, and VCC is the on state gate voltage. We have seen this thing. VEE is my off state gate voltage. Okay, so this thing you have already know. Now next thing is gate drive IC. So selection of gate drive IC is also very important. So you will see here that I have my isolated power supply, then I have my gate drive IC. So gate drive IC include the signal processor which will take a decision whether to pass the require signal or not based on the condition, whether the fault is there or not, whether normal condition is there or not, whether the sudden load change is there or not. So all thing will be processed by this signal processor, and based on that it will provide the gate pulse. Okay, so it provides the voltage. So what the gate drive IC will do, it provides the voltage to drive the switch into on state and off state with sufficient current to charge and discharge the switch input capacitor. Okay, so switch input capacitor. So you understood what I wanted to say, that it is with sufficient current to charge and discharge the switch input capacitance and low impedance with quick response for fast charging. So this gate drive will provide the sufficient current. Okay, so if I wanted to turn on any device, what is the important thing? So important thing is to provide the my current, amplify the current and give to the device under the test. And once the device capacitances are charged, so if I have my device, any device, the junction capacitances of the device. So once the capacitor input capacitance of the device is charged, my device is turn on and turn off accordingly. Okay, so this gate drive will provide the sufficient current to charge and discharge the switch input capacitance. Second thing is, the operating voltage range of the gate drive IC VGDI should be higher than the potential difference between the turn on voltage VCC and gate turn off VE. So this voltage level of the gate drive, what is the voltage level of the gate drive? So this is the first criteria. I would say that the voltage level of the gate drive IC should be higher than the potential difference. So VCC minus VE. Okay, potential difference between the VCC minus EE. So it should be higher than this. If I wanted to select the voltage level for my gate drive IC, so it should be greater than this VCC minus VE. Okay, so this thing you have learned. This is the one of the criteria. So the same thing is written down here, VCC minus VE. Then next thing is the second part. What is the second criteria is, the peak source and sink driving current of the gate drive IC should, I source or sink should be larger than the peak gate drive IG peak during the turn on and turn off transient. What I wanted to say, my gate current should be VCC minus VE divided by RG. So RG is my gate resistance, and that gate resistance basically it is different during the turn on and turn off. We will design the gate drive in such a way that it should offer the different resistance while turning on and while turning off. Okay, what is the reason for that? I will tell you in upcoming slides. But generally we prefer to have different resistance because we don't want losses to be very more. Okay, so that is the one of the case. Now the different turn on and turn off gate resistance are usually used to optimize the switching performance. Okay, so this is the case. Now next thing we will see, this is the case. Oh, okay, so this is how my gate driver current it is. Okay, so it is not like simple. So it should have some transient. So this is the what I wanted to show you. And again another criteria for selection of my gate driver IC are similar to the signal isolator. Several additional selection criteria for gate driver IC should be taken into the account. What are the different criteria? So signal transmission frequency range, propa x delay, distortion, specifically maximum and minimum signal transmission frequency. So this thing we should keep in your mind. Okay, but what are the two important criteria? So these are the two important criteria, that its voltage should be greater than VCC minus V and current should be calculated using this formula. So select the gate driver IC which will fulfill these two criteria. Okay, now we will move forward. We will talk about the gate resistance now. So what is the gate resistance? So you know that it will limit the current. Okay, because I don't want direct current to flow and burn my device. So we need the gate resistance. So by using the gate resistance, it will limit the current. So gate resistance is a gas pedal of the gate drive. It is called as the gas pedal of the gate drive. It controls the speed of switching transient. Okay, so what value of the resistance is there, based on that it will control the switching transient. Although a smaller gate resistance is preferred, the gate resistance must be designed properly to accommodate trade-off among various switching behaviors such as the switching speed, switching loss, crosstalk, suppression and switch states. Now I will tell you something from this graph. Okay, so I have some gate drive and in this gate drive what I have considered, I have considered the Rg gate resistance as 0. Now when the gate resistance Rg is equal to 0, how the behavior, turn on behavior and turn off behavior you will see. Now during the turn on you are seeing very high transient spikes are there, and during the turn off very low spikes are there. So why this thing is happening? Okay, so the over voltage and ringing during the turn on transient is more severe as compared to that of the turn off transient, okay, when I am using the Rg is equal to 0. So that is why it is very important to choose the two different resistances for turn on and turn off, so that this high over voltage and ringing will not happen. So during the turn off, even with a 0 gate resistance, I have very low spike, so I will use very less value of Rg. And during the turn on, I have to use some little bit bigger value of Rg, so that this transient will be less. Okay, so this is how I will choose. And this is the circuit. Okay, so during the turn on I will use one resistance, and during the turn off I will use another resistance. So this is how I will construct my circuit. Now we will come about the last part, that is a decoupling capacitor. You are seeing here the two capacitances. One is a C1 capacitor, another is a C2 capacitor. Okay, so this is the if you know the, you have just seen the overall structure, right? So from that overall structure, these are the two small figures. Okay, and the two capacitors C1 and C2. These two are the decoupling capacitors. So we will see here that what is the use of this decoupling capacitor and all. Okay, so these two capacitors are very important. So just theory is written down, and how to calculate this two value of the capacitance we will see. So the decoupling capacitor is the fuel injector of the gate drive. It provides the energy for the gate current pulse during the switching transient. The gate driving current originated from the power supplies VCC and VEE. However, the power supply cannot be placed in a close proximity to the gate drive and device under test due to relatively larger volume. As a result, large parasitic are invariably introduced as shown in the below figure. Okay, so parasitic will introduce. Therefore, it is necessary to place the decoupling capacitor locally with a small footprint and low ESL to bypass the power supply resultant parasitics and improve the gate drive dynamic performance. So what I wanted to say, that when I have my input supply, okay, so this is placed bit of more distance from the device under test. So what will happen, because of this my length will increase and parasitics will also increase. So to avoid that, I will use this decoupling capacitor, which will act as a source, and it will give the once it is charged, it will give the required voltage to my devices. So that is why these two capacitances are used, and these are placed very nearer to the device, so that with a smaller footprint, so that basically my dynamics will improve. Now how to calculate this? So the three criteria should be taken into the account for decoupling capacitor selection. What are the different criteria? So including sufficient voltage rating, so it should have the sufficient voltage rating, adequate capacitance, and minimize ESL. Okay, so these are the basic criteria for selection of the decoupling capacitor. Now how to calculate? So this is the thing just I have discussed. So how to calculate this capacitances? So this capacitance is calculated using the formula. So for C1, that is Qg upon VCC, and delta VCC. So delta VCC I will write it down, that K VCC into the VCC. So my K VCC and K VE are the coefficient indicating the two voltage variation percentage. So these are 1% to 5% we will select generally. Okay, you consider 1%, 2%. So in a problem which we are going to solve, there I will tell you how to select all these things. Okay, so this is how we calculate. So these are the all the components we have talked about for the basic gate drive. Okay, block diagram. So with this I will conclude this lecture. So thanks for watching. I hope so you have understood something from this lecture. So what is a basic block diagram of the gate drive? So gate driver IC is not the single part of the gate drive. there are the some different parts also which are there in the gate drive, and what are the parameter, what are the criteria for selecting the different parts of the gate drive, that we have seen. So in the next class we will solve one numerical problem, one case study problem, from where I will tell you that if I have my any particular device, so how I will design my gate drive for it. Okay, so thanks for watching. So if you want to use some references, you can refer this references for your reference, and you will learn something more from these references also. So thanks for watching. Stay tuned for the next lecture.